Hi viewers, today we'll understand about functional decomposition of a transceiver. This particular transceiver operates under the frequency of 27 MHz, which is unlicensed frequency channel. And this is how the transceiver circuit, the casing of the transceiver circuit really is. This is the casing, this is the storage for the power source. This is the speaker here, and this is the circuit board. This is the telescopic antenna that is used for for transmitting the signals. This is the transceiver, which I have removed it, which looks like this somehow. This is the place for the batteries. This is the circuit board. And this is the telescopic antenna. So as we remove it here, it gets opened up like this. This is actually a button for tapping in the Morse code, and this is actually the on-off switch for the transceiver. Even the Morse code signals have been printed out over in front of the transceiver. This is the place where we can listen over to the speaker. This transceiver supports both Morse code as well as verbal communication. This here is the button where if we can press it long enough so that we have to speak, and using some code language we can make verbal communication. But as long as that we make a communication, this button should be held in position in this way. Both the signals from the Morse code and also from the verbal communication is received through this speaker, and there is no recording for this circuit in this circuit, but we have to manually record any information that has to be given. A transceiver is actually both a transmitter and a receiver circuit coupled together. First we'll understand about functioning of a simple transmitter circuit. In this circuit we can see the microphone M here, and this is a transistor. This C1 and L1 parallel together is called a tank circuit, and here this is an antenna. Transistor has three different terminals: an emitter, base, and a collector. The base of the transmitter is directly coupled to the positive of the microphone. The emitter is further connected to this tank circuit, and the collector here acts as the reserve for the collection of the oscillating wave and also the modulating wave. I'll tell you about modulation and oscillation. Modulation is a process of encrypting information into the form of the signals. The information that we get is through microphone, and so this microphone tries to reduce the signal in the form of electronic signals. That is, the repercussions of the mechanical energy are converted to the electrical signals, and this is connected to the base of the transistor. Oscillation, on the other hand, is to bring in any signal into the required frequency. That process itself is called oscillation. This tank circuit actually acts as a resonator. It is an equivalent of a tuning fork. This tank circuit generates the required this tank circuit actually generates the required oscillating frequency that we need to transmit. The frequency required to transmit can also be changed by reducing the woundings of the solenoid. That is supported by a formula given. The modulating signal and the oscillating signal together is collected at the collector of the transistor. This collected wave together is emitted into the atmosphere by the antenna. However, the waves actually, to improve the power and to amplify the signal, this capacitance C3 is used, and also this resistor in parallel with C3 is used, so that the C3 and R2 actually act as the amplifier circuit to the emitting wave. The frequency is actually dependent upon the values of C2, L1, C3 and R2, and antenna actually acts as a medium for transmitting the wave. Now let us understand about a simple receiver circuit. Here the antenna is connected to the base of the transistor T1, and further the emitter of the T1 is connected to the base of the transistor T2. Here Vc is actually a trimmer, which is a variable capacitance in order to actually check for the frequency that we are trying to capture. This is a simple receiver circuit without any signal filters. Once the switch is closed, the headphones can be able to hear the signal that is captured here at antenna. This here, the capacitors and the inductor, which is connected in parallel, is actually the tank circuit. Here this is the trimmer. As we can vary the capacitance here, this acts as an oscillator circuit, similarly like that of here in tank circuit. It acts as an oscillator circuit. This oscillator circuit brings up the signal, modulated signal onto the base of the transistor T2, and the signal gets collected at the resistance R1. In order to increase the strength of the collected signal at R1, capacitance here is connected in parallel to the output device, which is the headphones. The capacitance actually increases the amplifies the power of the signal, and thereby we can have volume control over the headphones, but the volume control may not be efficient without this capacitance. This is actually a circuit diagram for both a simple transmitter and receiver circuit, and we'll further understand about the functional decomposition of a transceiver. Here the transceiver circuit is actually functionally decomposed into three major parts. This is a transceiver module, this is the transmitter circuit, and this here is the receiver circuit. We'll understand how things work. Here the solid line is the mechanical energy, the dotted line is the sound energy, and this is the signal energy. Signal that has to be electronic signal. This can be classified as electronic signal. From the transceiver module, the transmitter or radio, in order to work efficiently, this transmitter or radio requires mechanical energy, sound, and also the signal. Here if we have this option of verbal communication, also Morse code communication from this transceiver. So if the verbal communication is selected, then the electronic signal as well as the sound, which is the mechanical percussions, they reach the phase modulator, which is a circuit, phase modulator circuit. And Morse code communication is actually pass through another step, which is an encoder circuit. This Morse code actually generates signal to the encoder circuit, and this creates a beep sound, and thereby this also reaches to the phase modulator circuit. The phase modulator encrypts the sound into an electronic signal, and with the help of the oscillator circuit, it actually excites the signal into the required frequency, and the combination of both the signal and the sound is actually pass through the frequency amplifier in the next step. This amplifier increases the power. This amplifier only increases frequency. However, in order to sustain through long distances, it also needs to be increased in terms of power, so that a small amount of electric current is also used from the power source. So this power amplifier is thereby emitted by antenna. Antenna here has both functionalities, emitting as well as receiving. So the receiving part of the antenna is discussed in the receiver circuit. Here the RF tuned amplifier is actually set up to a oscillator circuit is actually set to that particular frequency which we want to hear the voice. In this case of this transceiver, as it is written here as 27 megahertz, this is actually nothing but the RF tuned amplifier is nothing but this variable capacitance and inductor solenoid L1 connecting in parallel. Sometimes there is also a local oscillator which is used in along with the RF tuned amplifier in order to get reduced noise in the signal. The signal that is received at a frequency of 27 megahertz cannot be heard by a normal human, is not audible actually. So this mixture actually reduces the frequency and reduces the frequency into the audible range and also electronically converted range, so that both the circuits actually have an ability to exchange the signal. As mixer reduces the frequency of the collected wave, this IF tuned amplifier is actually an intermediate frequency tuned amplifier that further brings up or stabilizes the frequency up to the required range, and this is connected to the limiter circuit. As intermediate tune amplifier increases the frequency, the limiter circuit allows only those frequencies that are admissible to the discriminator circuit. That is, the high peaked, or it actually attenuates the signal to the required range of the frequency. The signal then from the limiter circuit reaches to the discriminator or a demodulator circuit. Here this discriminator circuit actually intensifies the efforts of the limiter circuit, but however this is an automatic segregator where it separates the required frequency signals from the unrequired frequency ones, and also the noise is also separated efficiently in this discriminator circuit. However, the discriminator circuit may actually increase the frequencies of some of the signals, so there is a de-emphasizer circuit which is used to bring the entire frequency of the signal into a normalcy or a agreed frequency, and then this goes through the volume and tone control, which is actually computerized or hand controlled or gesture controlled magnitude. Many times the volume and tone control is actually set specific to the user or also to the company with which the speaker or receiver is, and then this volume control, the signal from the volume control is further carried towards the power amplifier in order to sustain the entire signal. This power amplifier uses current from the source. Only power amplifier here and here uses actually the source, the energy from the source, which is a DC battery. The battery is about 4.5 volts, and then this power amplifier further carries the signal towards the speaker or the receiver, where the speaker actually gives out the percussions as well as the sound energy as well as the signal, which is carried throughout the circuit. This is how the entire transmitter and the receiver in cycle act for a communication to transfer from one point to other, and it actually follows very long distance communications. The range for communication is about 5 kilometers for the frequency of 27 megahertz. It can also be greater than this, but however the signal, all these circuits that are attached onto the circuit board may not perform actively. So for a recap, this is a transceiver module, this is the transmitter circuit, the block diagram of the transmitter circuit, and this is the block diagram of the receiver circuit. Thank you for your valuable time, viewers. Thank you very much.